In this video, we look at a formula that's going to be very important for section 3.3, and this is like a key, idea, and formula. Right? So here's a key calculus idea. And just, an example should be enough to kind of get us an idea of what's going on here. So let's look at a function f of x is equal to x squared. Okay? And choose your favorite point of interest, which is, let's say, 2. That's my favorite value of interest for this function, because I can easily plug 2 into this function to get 4. Okay? So that's what I've done over here on the left side of the screen. This is essentially my calculator. Put 2 into the function to get an answer of 4. Okay? So here's a question. What is the function evaluated at 2.1? Otherwise known as, what's the function evaluated at 2 plus a little bit? And remember, in calculus, we're calling that little bit h. So f at 2 plus a little bit more. Okay? The flip answer is to just say we'll plug 2.1 into the calculator, and you get 4.41. Okay, so you get 2 plus 0.1, and then you'd square it, and that would lead you to 4.41. Okay, so if you have a calculator, do that. But again, what we're trying to address here is this key idea of calculus, which is the estimation idea. Estimate. Okay. And what we mean by that is we can say f of 2.1 is approximately something. We can find an approximation for it. Okay? And here's how we're going to approach that estimation idea. Right? Look at the function evaluated at x plus h. Okay? X being any point of interest, and h being some small change in x. Okay? And work out what that formula comes out to be. It's going to be x plus h quantity squared. So it would be x squared plus 2x times h plus h squared. Okay? And we have done something pretty profound here. For example, if you let x value specifically x be 2 and h to be 1, what we've shown here is that f of 2 plus 0.1 is equal to 2 squared plus 2 times 2 times 0.1 plus 0.1 squared. Now we already know the answer here. We already know that the function evaluated at 2.1 is 4.41, right? But what we've shown up here using this foiling formula is that 4.41 is 4 plus 2 times 2 is 4 times 0.1 is 0.4, and then 0.1 squared is 0.01. So what we've shown is that the function at 2.1 is really 4.41, but that 4.41 is 4 plus 0.4 plus 0.01. It's really made up of those three numbers, okay? Which is another way of saying that the function evaluated at 2.1, or the function at 2 plus 0.1 for h, is the function evaluated at 2 plus, and then 2x is what we were calling our derivative at 2 times h plus h squared. Right? Which says that if you want to approximate the function at 2.1, it's approximately just these two numbers, the function evaluated at 2 plus f prime of 2 times h. Okay? So where h is equal to 0.1. So if you're just interested in approximating, we can drop off some terms here, the higher value in h terms, and then you can say that f of x plus h is approximately the function evaluated at any x plus the derivative function multiplied by the small change in h. And this is a key formula that will get us a long way in calculus and also help us develop a product rule formula. A product rule formula. Okay, it also happens to be a key idea in calculus, this approximation idea. So that's the end of this short video. I just wanted to kind of give a quick illustration of what this function was doing. You may want to, try the same thing. If the function f of x is, say, x cubed, and you pick a specific value, say 4, and then you pick an h value of 0.1, can you show that what the function evaluated at 4.1 is, right? The exact value, right? And then can you do the function evaluated at 4.1 approximately using the formula given below here? Okay, so that would be a question that you could work on. Okay, so very important formula we've just developed here. We'll use it a lot in this calculus class.